Hi, I'm Mike Rowan. Welcome to Part 5 of Retro Printing for Fun and Profit, sharing new and old printers with new and old computers. In this episode, we're going to begin the work of connecting the color computer serial port to the Raspberry Pi.
We want to connect a Tandy color computer to our Raspberry Pi Zero wireless. The CoCo uses a 4-pin DIN for its serial connection. Well, we don't have that available on the Raspberry Pi Zero. So whether we use a module like this for TTL to GPIO on a Raspberry Pi, or we use a USB to serial cable, we're still looking at using an industry standard 9-pin connector, a DB9, for RS-232 connection. Now, later we're going to look at using a GPIO module, using the GPIO pins on the Raspberry Pi. But first we're going to cover using a USB to serial cable, just because it's easier to start out with. And I'm also going to take a moment to plug StarTech. I don't get compensated from StarTech, but there are several reasons that I prefer using StarTech. They're fully supported on Windows, Mac, and Linux. The FTDI UART can support 921.6 thousand bits per second, so very speedy. The other pins are active, they're set high, not just transmit, receive, and ground. So I get RTS, CTS, DSR, DTR built into there. So I get all of the signals that I want, and most of all, it's optically isolated. What that means is that if I accidentally plug 500 volts into one of these pins here, it'll blow up this connector for sure, but that voltage is not going to travel down the USB and blow up my $2,500 laptop. That's cheap insurance the way I see it. They make high quality products. These are now very affordable. They're $18 on Amazon. So a little more money than you might pay for, but you get a whole lot of insurance for that price. And the other thing I recommend you get when you're first setting this up is get a DB9 Breakout Adapter. This has screw terminals on it. It has all of the pins labeled with their RS-232 purpose, and that will make it easy for you to troubleshoot and get it right the first time. And they actually sell a model of this that comes with a hood, so you could actually use it as the permanent connector for your project as well. These are about $6 on Amazon. So now let's take a look at how we're going to wire these two things together before we actually start building a cable and doing some tests.
Let's review the RS-232 signals on the color computer, and we'll assign the wire colors we're going to be using in our cable. Pin 1 is the CD input line. We're not going to be using this signal at all, so we're just going to ignore it. It's not going to be connected in our cable. Pin 2 is the RS-232 in, the serial data input line, but we're not really using it to transmit data. It's really the flow control status line that we talked about when it was connected to the printer, and the Raspberry Pi is really going to be playing the role of the printer connection in what we're doing anyway. So let's call it that. We'll call it the flow control serial data input. Pin 3 is the ground line, and that's going to be our red wire in our cable. And pin 4 is the RS-232 out, serial data out from the CoCo to the Raspberry Pi now, and that's going to be represented with the black wire. This is our first look at the DB9 connector. It's the DB9 Breakout connector that we saw earlier. The pins are numbered 1 through 9, but we're only using 3 wires from the CoCo. That's going to be pins 2, 4, and 5. Pin 2 is the RxD or receive data line. This is where we'll connect the black wire. Data from the CoCo will flow to the Raspberry Pi on this line. Pin 4 is the DTR or Data Terminal Ready line. This is an output from the Raspberry Pi side, and it will flow to the CoCo. This is the status line that we spoke of for flow control. It will use the green wire. Pin 5 is ground, and it will connect to the ground on the color computer side. This will be the red wire. So this is going to be the wiring diagram for the cable that we need to connect our color computer to the Raspberry Pi. Pin 4 on the CoCo will connect to pin 2 on the DB9. This is the RS-232 out from the CoCo, and it's the receive line input on the Raspberry Pi side. This will be the black wire. Pin 3 on the CoCo will connect to the pin 5 on the DB9. This is the ground on both CoCo and the Raspberry Pi. This will be the red wire. Pin 2 on the CoCo will connect to pin 4 on the DB9. This is the flow control status line input on the CoCo side, and it's DTR or data terminal ready output line from the Raspberry Pi Zero. This will be the green wire. So when we connect this cable between the Raspberry Pi and the color computer, data will flow from the color computer across the black wire, and the status line will be high or low, will flow over the green wire. And this is what it will look like when we have the DB9 Breakout connector wired up.
Okay, so we have the cable built with our Breakout DB9 on one end and our 4-pin DIN on the other. So let's connect everything together. So we'll start from our Raspberry Pi here. We're going to connect our USB to serial adapter. We'll plug that in. So that's plugged into the Raspberry Pi. Then we can connect the 9-pin cable end into the serial adapter. And then finally, we'll connect the 4-pin DIN into the RS-232 port on the color computer.
This is an excerpt of the color computer memory map as shown in the Color Computer Technical Reference Manual. At address FF22, we can see the 8 bits associated with several functions. We're interested in bit 0, and as you can see, it's the RS-232 data input line. So it's tied to pin 2 on the RS-232 serial port. That's the pin that is being used for flow control or status. So from the CoCo, we can use the peek command to look at the 8-bit value at FF22. But we can't rely on a static value when we do peek because bits 1 through 7 may be in different states depending on what's happening inside of the CoCo. But since the RS-232 data input is connected to bit 0, we can at least determine if the value at FF22 is odd or even. If bit 0 is set to a 0, we know that the value at FF22 will be even. And if the value at bit 0 is set to 1, we know that the value at FF22 will be odd. So let's look at this from the RS-232 signal perspective. The input to pin 2 gets inverted before it arrives at the PIA pin. The box on the right is the value seen at address FF22 bit 0. If we connect pin 2 to a low input, the inverted output at FF22 bit 0 is a 1. If bit 0 equals 1, the value at FF22 is odd. So this means that the attached device is not ready. And if we connect a high to pin 2, the inverted output at address FF22 bit 0 is a 0. If bit 0 equals a 0, the value at FF22 is even, meaning that the attached device is ready. So let's look at the FF22 address on the color computer and see what we can see. Alright, so from our color computer we just need to write a quick program. So we'll just do a print at 32 peak and H FF22 and 20 go to 10. So we're just going to keep peaking over and over and over so we can see that line transition. So when I run this, we see that we have an odd value, meaning that the device is not ready, even though it's plugged into the Raspberry Pi. The reason for this is that the device has not been opened on the Linux side. So until something actually goes and opens the TTY device, our serial device, our USB serial cable, none of the pins will go high. So we don't have a signal going to the color computer yet. I have a terminal window open here, logged into the Raspberry Pi Zero. Let's do an LS USB to see what's on our USB bus. And there we can see it. This is our USB to serial adapter, the Future Technology Devices International, FTDI. You can see it's a 232 serial UART, and that is definitely our cable. So we know that the cable is plugged in to the Raspberry Pi. Now let's see what the device is named. Linux should automatically, when it detects these kinds of devices, create a device called TTY USB 0. If I plugged in another one, it would be TTY USB 1, and so on and so forth. So if we do an ls-l of /dev/TTY asterisk for wildcard, it'll list all of our TTY devices that are defined. And there are several hardware TTY devices that are always sitting out there, but there's only one USB device. It's TTY USB 0. So the reason the color computer doesn't see it yet is no program is connected to that device. Nothing has opened the device for read-write. To do that, we can simply type cat, and we'll redirect input to cat from /dev/TTY USB 0. And we'll hit enter. And as soon as we did that, you can see that on the color computer we now have an even number. That's showing us that the device is now ready. So if we were going to communicate with a CoCo, that would be the first step, is we have to set that status line high. The way it's wired, it'll automatically put that DTR signal high as soon as we do anything to open the serial port from the Linux side. Now I'm going to unplug the cable. So when I unplug the cable from the serial port, you can see that it goes back to an odd number. But when I plug it back in, it goes to an even number. So if I hit Control-C here, then it will automatically close the device, and you can see we now have an odd number displayed on the CoCo. Well, this is the end of Part 5. We successfully tested the flow control status line between the Raspberry Pi Zero and the color computer. In Part 6, we will write a bash script to capture data from the color computer. I'll see you soon in Part 6, and thanks for watching.